All right, we ready? We're going to cover three things today. We're going to talk about, well, we're going to review simplifying radicals, because theoretically you should have done it already. Some of you may have struggled with it, but we'll get there. We're going to talk about Pythagorean Theorem. You've all done Pythagorean Theorem before, right? Yeah. Beautiful. And then we'll talk about the distance formula, which I'm sure you've also done, but I don't know if anyone's ever showed you where the distance formula comes from. They probably just said, here, do this, and then you crank out some numbers. So let's start with simplifying radicals. Square root of 72. You could fire up your calculator, do so please, and tell me what the approximate value of the square root of 72 is. Now before you do that, hold on. Guesstimate what the square root of 72 is without using your calculator. What is it?
7.
I'm sorry?
I was like 7.5.
Why?
Because 8, no, never mind. I was gonna say because it'd be more than 7 because 7 times 7 is 49.
Okay. How much more than 7? Would it be more than 8?
Yeah.
Because?
8 times 8 is 64.
Good. Would it be more than 9?
No.
No. So what do we know?
8.5.
Somewhere in between 8 and 9. You think it's closer to 8 or closer to 9?
Closer to 8.
Any particular reason?
Because 72 is closer to 64 than it is to 81.
Beautiful. Solid logic. Now tell me what it is. Well done. Okay. So that's the approximate value. The approximate value would be a decimal form. We're not talking about that when we're simplifying radicals. We want it to be in a different form, but still an exact answer. Anybody remember how to do that? Bella?
You can do 9 times 7, and then you could do...
Wait, hold on. Let me get my pen working here. Okay, you want to rewrite this as what?
9 times 7.
9 times 7. Still under the radical?
No.
No, get rid of the radical.
Yeah.
Okay.
And then you could take the square root of 9, which is...
Whoa, hold on. Technical difficulties. So just write it as 9 times 7.
Yeah.
Where'd the radical go?
Well, it'll come back. Well, like 37.
It's like magic?
Yeah.
Okay, so you made the rabbit disappear,
Yeah.
and now you're going to make the rabbit reappear.
Yeah.
All right, go ahead.
Now you take the square root of 9, which
I
is...
can't though, there's no radical symbol.
Oh, okay, then put it under the radical.
All right, put it under the radical symbol. That's better. Now what?
You could take the square root of 3, and then it'll move to the outside of the radical, and it'll be 3 square root of 7.
I'm going to add a couple more steps here for people that are a little shaky.
Okay.
If you have the square root of two things multiplied together, you can rewrite it as the square root of 9 times the square root of 7. Right? And what's the square root of 9? 3. Now there's one small mistake here, Bella. You see it yet? Your radical work is outstanding. Don't see it? Dana?
9 times 7 isn't 72.
Yeah.
Oh, it is.
No, 9 times 8.
Oh, I'm sorry.
That's okay. Your brain just grew. All right, so let's fix this. Now, Bella, back to you. Why did you choose 9?
Because it's easy to take the square root of.
What is that called, by the way? A number that it's easy to take the square root of. Caroline. Caitlin's in the back there, right? Caitlin, okay, go ahead.
Perfect square.
That's perfect square. So you got to know the perfect squares. What are they, Caroline?
9 to the square.
Can you list them in order? I'll give you the first one. 1. Because 1 times 1 is 1.
9,
You skip 1.
2, 4,
4. Good. 1, 4.
9,
9.
12,
No. 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16. 5 times 5, 25. 6 times 6, 36. 49. 64. 81. Hundo. Keep going. Buck 21.
144,
144 is a gross. Done.
13 times 13,
Which is
160,
wait.
160,
No.
169.
169. So pretty much need to know up to like 12 or 13 because we're not going to do numbers much bigger than that. Okay, so Bella recognizes 72 can be written as the square root of 9 times the square root of 8. Simplify the square root of 9 to be 3. Now, a common mistake that people make when they're simplifying radicals is they forget to get rid of the radical symbol. Once you take the square root of a number, the radical symbol over the top disappears. Okay. Now, there's a small problem with that in that we're not done. Why? Caleb.
Well, 8 can be, x squared of 8.
Yeah, we can keep going here. Doesn't make it wrong, it just means we have to do a little bit more work. So 3 times, what goes into 8 that's perfect square, Caleb? 4. So I can rewrite 8 as the square root of 4 times the square root of 2. Square root of 4 is?
2.
2. What do I do with the 3 and the 2 then? Multiply them. So 3 times 2 times the square root of 2. 6 square roots of 2. Okay, so you're not sure if you simplified the radical correctly. Well, type 6 square roots of 2 into your calculator. Go ahead and check it. Beautiful. To make your life a little bit easier, because notice we had to do 2 steps. We did 1 step to get the 3 square roots of 8. Then we had to do another step to get us down to 6 square roots of 2. To make your life a little bit easier, your goal should be to find the biggest number that's a perfect square of 72. So what else goes into 72 that we could use to start over? 36 times 2. What's the square root of 36?
6.
6 square roots of 2. Is one of these more corrector?
No.
No, just look, same. Just a different way to get there. As long as you get there, that's all that matters. So as you start breaking down that radical, when you get to the point where you think you're done, you want to ask yourself, do I have all the perfect squares out of there? You've done this before, right? Starting to come back to you? Good. Then try that one. Jenna, what do you have for a radicand? Do you know what the radicand is? Everybody know that term, radicand? That's a number underneath the radical symbol. What's your radicand? 5. Yes? Everybody agree that that should be a 5? Good. What's the number out here then, Jenna? 2. Beautiful. How'd she do?
Good.
Excellent. Any other way to do that? Pretty much 4 times 5. Square root of 4 times square root of 5. Square root of 4 is 2. 2 square roots of 5. Done. One more example for you. Try that one. And again, remember when you're simplifying these radicals that there are numbers that will go into that radicand that aren't necessarily perfect squares. You could write the square root of 90 as the square root of 45 times the square root of 2, but neither one of those are perfect squares, so you're just wasting your time. You want to write it as a product of a perfect square and another number. What do we got? Max?
3 square roots of 10.
3 square roots of 10, perfect. Any problems? Square root of 9 times square root of 10, square root of 9 is 3, 3 square roots of 10. Okay? So we're going to take that idea of radicals and extend it into the Pythagorean theorem. So this is the actual Pythagorean theorem. Okay? In a right triangle, the sum of squares of the measure of the leg is equal to the square of the hypotenuse. However, you probably know what is that, correct? A squared plus b squared equals c squared. Let's get some terminology out of the way. What is this yellow thing? It's a triangle. What kind of triangle? It's a right triangle. Why is it called a right triangle?
That's right angle.
Got a right angle. That's what that little box means down there. First of all, remember the Pythagorean theorem only works for right triangles. And I know we're getting a little bit ahead of ourselves because we just talked about points, line segments, lines, and planes, and now all of a sudden we're diving into triangles and right triangles and all that other fun stuff, but that's okay. The two shorter legs are called legs. The longer leg, hypotenuse. Be careful with a squared plus b squared equals c squared. If the sides aren't labeled as a, b, and c, you're going to run into problems. Take the two shorter legs, square each of them, and add them up. Set it equal to the square of the long leg, which is also known as the hypotenuse. How do you find the hypotenuse in a right triangle? Max?
The diagonal line is the longest.
And how do I find that diagonal line? Because what if I flip that thing around?
It's the one line where none of its angles are right.
I like it.
The line across from the right angle.
The line segment.
Yes.
Across from the right angle, good. Okay. Longest side, the one not touching the right angle, the one across from the right angle. Okay, so try those. Or try that one first. I got another one for you after we do this one. I gave you two measurements. You have to figure out if those two measurements are A and B, or A and C, or B and C. It doesn't really, I mean, A and C and B and C are the same thing, but what information am I looking for? Okay, we got it? Am I looking for the hypotenuse or one of the legs? How do you know that? I didn't use the word hypotenuse up there. Ivy. Ivy, I was close.
Well,
It
it
begins
says,
with an A though, right?
yeah.
Okay, good.
It says the two shorter sides measure 5 and 12.
Beautiful. Which means that the third side and we know it's a right triangle, so the third side has. So what equation did you set up?
So I did a 5 squared plus 12 squared equals c squared,
I like it.
and then I did the square root, the squares, and then
The squares.
yeah,
Yeah.
And then I did 25 plus 144 equals c squared. And that equals 169 equals c squared, and then I did the square root. And it's 13 equals g.
Turned out to be a nice, pretty answer. Okay, so this answer is the exact answer. If the problem was strange enough to ask you for the approximate answer, it would also satisfy the condition for the approximate answer. Okay, because it turns out to be something pretty. That, by the way, is called a Pythagorean triple. When all three sides give you nice, pretty integer answers, we get what's called a Pythagorean triple. There's a whole bunch of them. 3, 4, 5 is another example. Any problems here? We're all good on that one? Beautiful. Let's take a look at the second one then. It doesn't say what form to give your answer in. So let's do both. If it doesn't turn out nice, like 13, then give me both the approximate value and the exact simplified radical answer, if that radical can be simplified. Some radicals cannot. Got it? Got it. How are we doing? Good. Not so good. Okay. Okay, tell me your name.
Jack.
Jack, what do we got? Well, hold on, let me ask you a couple questions before we dive into this. Am I looking for one of the legs or for the hypotenuse?
One of the legs.
One of the legs. So then either the 14 or the 25 has to be the hypotenuse. Which one?
25.
Because it's the longer one. Okay, so what equation did you set up?
A squared plus a squared plus 14 squared is equal to 25 squared.
How do you do so far?
Good.
Good. Carry on.
So I did a squared plus 196 equals 625.
Uh-huh.
And then I subtracted 196 to 625.
429.
Yeah.
Whoops. There we go. Then what? Square root of both sides? And you got that ugly monstrosity? Let's do the easy one first. What's the approximate value of that? Plug it in your calculator. Anybody? Oh,
20.7.
say again?
I got 20.7.
20.7. Okay, let's round to two places. 20.71. Okay.
So you can just round it.
I'm sorry?
Can't you just round it to 7?
No, I want to go two decimal places. Jack, any idea how to simplify 429 as a radical? I don't either. Should we play with it for a little bit? Anybody able to simplify square root of 429? What's, let's try some numbers. I know 4 doesn't go into it. What's 429 divided by 9? Is that a nice answer?
No.
Okay. How about 429 divided by,
It's
3.
what's that?
11 divided by 11 is 39. But that's-
Oh, 429 divided by 121. No?
3 works.
But 3 is not a perfect square. 9 doesn't work? Okay, so in that case, we just don't do it. Exact answer would be this. It's possible that the radical can't be simplified. Our approximate value is that. The problem didn't specify which answer to give. So you could give either one. Just be careful that if you decide to, if you decide to stay with a square root, it needs to be a simplified square root. And I don't think that simplifies, so we leave it as that. Question?
Wouldn't 14 be the answer though? Since it's asking for the shortest side.
Ooh.
Ooh. What?
Somehow I don't think I meant that as a trick question.
Got him.
Nice. It's a good one. Yeah, technically speaking, it would be 14. I wouldn't do anything that sneaky though. It's just a mistake on my part. Good, yeah. All right. Are we good? Can I erase? All right, let's talk about the distance formula. So we got a little coordinate plane here. And I'm gonna put a couple random points on the plane. Don't worry about where the points are. I'm just using them for reference. So I've got 2 points, x1, y1, x2, y2. You should be familiar with that notation because we used it for the midpoint formula. We good so far? By the way, does anybody know the distance formula right off the top of their head?
X1 plus Y1, in parentheses, X1 plus Y1, comma, X2 plus Y2, parentheses.
No, because you got some square. Rexon.
X2 minus x1, comma, y2 minus y1.
Closer, but no. We'll get there. What I want to find is that distance, d. Okay. So again, it doesn't matter that they're both first in the first quadrant. They could be anywhere on the graph. They could be positive. They could be negative. It doesn't matter. In order to get this to work, we need one question answered. And that is, how long is that little red segment? Now, you might be tempted to say, okay, wait, it's 1, 2, 3, 4, 5, 6, 7.5. No. Remember, these can be anywhere, so we want to find the length of that red segment based on those 2 coordinates. Sure.
It's the distance, I was thinking like take like the axis length, so like the y value of the bottom point, and then you get the 2 ends of it by doing the the y value of the bottom point and the top point, and then you have the line right here.
Beautiful. Now tell me how long it is.
You take the top one. Well, I noticed there's 3 spaces under it, so if you take the top one,
Nah,
you have
spaces
to-
don't matter, because remember those points can be anywhere.
Yeah.
Okay, so what he's trying to work out, and I'll let him stew for a second while I draw a picture for the rest of you. If that's a triangle, if the, seven, that's a 7. If that's 7, and this is 3, how long is that? 4. That worked. Okay, good. I think we're back to normal. If that's 7 and that's 3, that's got to be 4. You with me? Okay, back to you, Charles.
So I figured it out now. You take like the top one that you got for the top points y value and subtract for the bottom points y value.
So how long is the red segment?
So hang on, if I need to count where's the top. I need to count what y value it is.
You don't have to count. I told you what the y value is. What's the y value of this point?
Y sub 1.
Y sub 1.
Oh.
Because remember, it can be anywhere. What's the y value at the end of that segment?
Y sub 2.
So therefore, how long is the red segment?
Y sub 1 minus y sub 2.
Beautiful. Everybody, that's an important point, so I want to make sure everybody's good on that before we move on. The 7 and the 3 and the 4 thing should make sense because we're subtracting. Same thing is true here. However high this point is, minus the bottom will give you the distance there. So we get that. y1 minus y2. Okay. How long is that blue segment? Go.
x1 minus x2.
Beautiful. And what kind of triangle did I just make?
Right triangle.
Right triangle. What works in all right triangles?
Pythagorean theorem.
Pythagorean theorem. Okay, so let me stop for a second. Is everybody with me? If now, speak now or forever hold your peace. You're okay with where these values came from? Top minus bottom, right minus left. If I apply a Pythagorean theorem, then I would take, which one's the hypotenuse, by the way? The black, the red, or the blue?
Black.
The black, good. So then if we apply Pythagorean theorem there, we get d squared is equal to y1 minus y2, quantity squared. That's a squared, plus x1 minus x2, quantity squared. And remember, you can do these in either order, it doesn't matter. But I don't want to know d squared, I want to know d, so how do I get d by itself?
Square root.
Take the square root of both sides. And when you do that, you end up with the distance formula. And I know you've worked with that before, but I'm guessing no one ever showed you where that came from. And it's kind of a weird thing that you could start with either one. We could have started with the distance formula and derived Pythagorean theorem, but I chose to go the other way, Pythagorean theorem to distance. Question in the back?
They keep the squared even though it's already being squared.
Yes. Because the square root of a squared plus b squared is not a plus b. They don't cancel because of the plus sign in there. Okay, we good? All right, let's try it. Exact distance means your answer will have a radical symbol in it, or it'll be a nice, pretty answer. Once you get an answer, check with your neighbor. See if he or she has the same answer. Most common mistake when working with distance formula is sign errors. People forget how to subtract a negative number, or they forget a sign, or they get the pluses and the minuses in the formulas confused. Minus is inside parentheses, plus outside. David, how'd you set it up?
So I said d equals in parentheses -3 minus 4 squared plus in parentheses -5 and I just put plus 6 and
Sure you can.
Cancel out square.
Did everybody set it up the same? So you all chose -3, -5 as x1, y1. Anybody do it the other way around? So we'll see if you get the same answer. I would think you probably would, right? Otherwise we would have talked about that. Back to you, Dave.
Okay, and then I like simplified it in the parentheses and it's -7 squared,
Which is?
49
Good. What happens when you square a negative, everybody? It becomes positive.
and then I got 1 squared, which is 1, and then that equals 50.
We all done there? No? Why not?
Wait. Because you can simplify it.
Yes, you can. What goes in it? Did you simplify it, David?
Yeah.
Go.
So I did the square root of 25 and the square root of 2.
Good.
I got 5 squares.
Well done. Distance is always positive. In this class, the idea of a negative distance doesn't make any sense. That won't always hold true, but for us, distance is always going to be positive. And again, this says exact distance, so you should leave it in this form. When we get into word problems and things like that, this isn't going to make any sense. You're not going to go to the store and order 5 square roots of 2 fencing. We're going to convert that to a decimal value. I have another example, which if you want more practice, you can do on your own. But day 4 tonight, and don't forget there's a quiz tomorrow, so please study for that quiz. Have a great day, everybody.